not going so well.
I saw that last week.
All right, so today, we are still working with radicals. We're gonna do some simplifying style.
Why?
I didn't have. I
hate
myself.
I hate myself.
It's all on.
Give me square ball.
Help me. Give me work.
Exactly. I want to go to school. Well, then
We don't have to take that thing.
no.
All right. Hey, hush. We're getting started.
That was an awful eagle head.
Okay.
I don't see it.
So, we have worked with radicals. This whole chapter. Hey, quiet. Okay. We have worked with radicals all chapters. This whole chapter. And we are going to still be working with them. But what we haven't really looked at yet is radicals and exponents that are fractions are actually really related. So if I have the nth root of x, where n is my index, that is the exact same thing as having x to the 1 over n power. In other words, I can convert from radical to exponent form just by making my radical into a fraction. The 5th root of x is really x to the 1 over 5, like that. The index is going to be the same as my denominator.
Look at this.
5 over 9. Yep. This next one, the 9th root of 5, is really the same thing as 5 to the 1 over 9. That's it. Let me rewrite
We
that.
should have stopped
That's
this
supposed to be
at
next
the
one.
test review. We're gonna forget all this next week.
Alright, so let me just write this so it looks a little better. That'll be 5 to the 1 over 9.
No, it is not.
No, it's just to start you out.
Oh, and then we have to like
All right.
put them together.
First thing, last problem, I want you to rewrite the square root of y in exponent form. And I'll give you a little bit of a hint. What's the index on this, even though we're not writing it?
11.
Dude.
7.
I got
Give me a hint.
my
How's it
answer.
2?
It's just always 2 if there's not one there.
I got 2 squared to the
It's
5th.
always 3.
No, don't even start right now. I missed the last 3.
I mean 2 squared square root
She
5.
knows it, and she's missed the last thing.
Yeah.
I have
Watch your language.
2 squared square root 5. Is
Okay,
that right?
Good day.
Alright, so let's start off with Alright, so let's start off with James. What is my, no equals, what is my
Hey, this
square root of
one's
y
just seven.
in exponential form? Y to the what?
2 over 1.
Other way around.
1 over 2.
1 over 2. There you go. That is really y to the 1/2. And you'll see why we want to do this in a minute. Alright, not too bad.
It's
Okay, so we are going to simplify, but it's going to make it a little bit easier because do you know what 216 to the 1 over 3 is?
Wait.
I can type it in though.
You could. Or we could simplify it the way we've done before. So,
There it is.
we can actually wait, hang on. Let me, did I put these in the right order?
answer.
Yeah. Okay. So, not only can we go from radical to exponential, we can go backwards. If I'm going to rewrite this as a radical, I could write this as the cube root of 216 because the index and this denominator are the same, right?
Yeah.
We've simplified cube roots like this before, right?
No, never mind. Just kidding.
So I can change this around now and say, well, let's find out something to the 3rd times something else that equals 216. We've done that before.
Yeah, it's just 7.
What?
This is over
What about this one?
Most of it.
These
I
are
know that's
pretty
most
easy.
of it. All right, Devin, what do you get for you? What to the 3rd?
2.
2.
Oh,
6.
crap.
So 6 to the 3rd actually equals 216. So I can go in here, I can replace this to be the cube root of 6 to the 3rd. And what does my index of 3 do to my exponent of 3? Cancels out, right? And it kicks the 6x, the 6 out. And is there anything left in my radical?
Zero.
So I just leave it like that.
0.
Alright. Let's look on B here, because we're going to try to do these without decimals, even though you could probably plug them into decimals. We're going to try to do it without.
Can't.
So if I have 7 to the 1/2, I can rewrite that as the square root of 7, right?
Yeah.
times square root of 7.
So it's just 7.
What's square root of 7 times square root of 7?
22.
Just 7.
Gosh, it's 11.
So it makes it easier to simplify.
Wait, so that'd be the same like B.
Yeah, because it's itself times itself.
And then
3 times 12.
Don't spoil it.
I'm just.
Yes, fine. We'll go with Thomas, and he says, "No, which one of the same thing for B?" Alright.
the
Alright,
36.
let's look at part A now. I have 64 to the. I actually can't even see what that number is right there. Is
2.
that 1/2?
Yeah.
Alright. So I can rewrite that in my
You can't
radical
do
form, make it square root of 64, which I know off the top of my head.
Is 3
That's 8.
Wait,
times
so we're just doing numbers, like it's just equal to one number.
Not always. Let's look at this one.
Oh.
Let's do part C together.
Colton, can I ask you a question? This is the most important question.
So it's going to be
Do we just, can
3
we just forget about decimals? Do we have to
times
write decimals down?
No decimals.
2
Oh, thank God.
squared 3
That's the whole point of this chapter. No decimals.
Yay.
Alright, so we are actually going to do part C together.
to the third.
Alright, so I have 3 to the 1/2
Is that the yes?
times
Yeah.
12 to the 1/2.
Oh, it's 3.
If I convert these
No, it's
into
This is 1.
radicals, I have
It's 2
square root of
squared.
3 times square root of 12, right?
Mm-hmm.
Which, I know how to actually multiply these together, don't I?
Oh, no.
Because I can just go square root of 3 times 12, which is square root of 36, right? What is the square root of 36? 6. That's my 5.2. So,
wait.
it's nice to go back and forth because I can't do 3 to the 1/2 times 12 to the 1/2 in my head. But I can do square root of 3 times square root of 12 in my head. That's a square root of 36, which is just 6.
I didn't do it like that.
But wait.
Did you reduce this and go like
Yeah.
like 2 square root 9? You get 2 times 3?
No.
No.
I did it wrong then. I don't know.
Oh, I think you were thinking of adding instead of multiplying.
Maybe.
So how
So I
come
did it right.
you're not using the little thingy
Always
on the
comes
outside
down
now
to
that I can't
this.
remember the name of?
Index?
Yeah.
Because.
Why
they're
can't this be all we do?
'Cause- Oh, okay.
That would be way more easier.
Alright, it's not too bad so far.
Yeah, yeah,
so-
exactly.
These are actually really similar to what we just did.
Kind of.
So, what I did last time was I went from we went back and forth between exponential and radical. So I went from something like x to the 1/2 equals square root of x, right? Well, I'm also gonna show you guys how you can go from something like x to the 3/2 into radical form, and it's really not that much harder.
X to the third.
So when I have a, whatever, if a is a number here, whatever it is, to the m over n is your index, and m stays as an exponent. So your denominator is your index, and your numerator is your exponent or power. I'm actually going to rephrase that. I like saying exponent but not power.
Why do you put denominator on top?
I don't know. That's a good question.
Wow.
Cause the
One that I
D
cannot
before
answer
N.
right away.
Cause
That's gonna confuse me.
Then look around yourself then. You don't have to write it in the same way.
I wrote it in pen. I can't.
Just cross it out.
Nope.
I rewrote it.
Alright, so I'm going to write x to the 3 over 7 in radical form.
Right there.
Alright, so I'm going to write x to the 3 over 7 in radical form. So I'm going to have a radical here, right? Okay? What's my index going to be?
3? 7.
7.
Okay.
My index is going to be my denominator.
Oh,
So my index is 7. And then inside here, I'm just going to have x to the 3. That's it.
Right?
That's all you need.
Are you for real?
Yeah.
Are you for
So
real?
equal
The
sign?
type is y
Actually,
negative.
that's
Definitely not.
It's negative 2.5.
Alright, let's look at y to the negative 3.5. Is this a fraction, negative 3.5?
Yes.
No.
Negative
One
2.5
Not right
over
now.
1.
Can we turn negative 3.5 into a fraction?
Technically, it's
Yeah,
always a
we put a one
fraction.
Well, we could put a 1 underneath it, but that hasn't really changed anything, right? Can you think of something divided by something that equals 3.5?
Positive, no, negative 3.5.
7.
Yeah, negative 3.5. 7 divided by what?
2.
2, right?
Negative
7 divided by 2 is negative 3.5. So, if we get a decimal,
This is
we can
over.
change it to a fraction without using 1. But we don't want any decimals. So I'm going to go y to the, let's just go negative 7 divided by 2. If I'm going to change that into radical form, what's my index?
7.
Index is 2, right?
2.
And I'm not even going to write it because when the index is 2, it's, yeah, we don't need to write it. And
Ah,
then inside here, I'm going to have y to the what power?
7.
Negative 7.
Negative 7.
Negative 7.
Okay. Not too bad.
Are you even recording?
I think so.
I was still laughing.
I don't know. I'm not going to check it though. I don't feel like it.
Check it.
Alright, so for part B here, we're going to flip back and go the other way now. We're going to write the square root of a to the 5th in exponential form.
Wait, what?
We're going to write the square root of a to the 5th in exponential form.
Okay, so instead of it having the little fraction thingy, we're
We're just,
flipping it around.
we're just doing
and
first
we're
like this
making it a little fraction.
Yeah, we're making a fraction.
Gotcha.
Okay, there, Doug? Alright, so I've got a, I'm going to have a little fraction here. What is my denominator on this fraction going to be?
2.
2. What's my numerator going to be?
5.
5. That's it. Alright. And one thing to keep in mind, so I'm doing the 5th root of b and then outside parentheses to the 3rd, like this. Where the exponent 3 is doesn't matter. It could be inside under the square root or it could be outside of parentheses here. So it's the exact same thing either way. So the 5th root of b and then to the 3rd is exactly the same as if you put your 3 right here. So I'm going to have b to the, what's my denominator going to be?
5. 3. Oh, 3.
Denominator.
Oh, see, I was right. Oh.
Denominator is 5. Numerator is 3. Just like that. Alright, next, 2 in class problems. Write the first one in radical, write the second one in exponential. What's the index on the square root? Write the first one in radical form, write the second one in exponential. Turn to listen and on your phone, double whammy. Take that phone right now and drop it.
Wait, do we have a negative exponent?
Yes, we actually are going to simplify those a little bit more probably here in a minute.
Or not
Four,
completely.
I said that in my head.
Me too.
Easy.
Okay,
No,
so
what's
we
wrong?
got
Yeah, what is it?
I was about to over yesterday.
Here's up, here's up.
Oh no, Jaden Moore, you're doing hair.
Heinrich was pissed.
That makes sense.
Yeah.
Hey, right here.
Wait, so Goku, I was called you Heinrich. I call Goku Heinrich.
You see all this?
I know, I don't know why I guess you can do it. So are you gonna put this like something and then negative 4?
He's like,
Oh, God,
man.
yes.
Oh,
Did it really?
yeah.
Radical.
Can I get some quotations to look back down and see
Well,
if
they're
we're too
staying
far?
with a friend right now. Just
Okay.
Kobe said that loud.
We just moved out where, well, I moved
then
in
this one is
out like 2
Log
years
number
ago,
4.
And you just haven't found a new apartment.
Log.
Wait, what?
Log
Where
1.
did Brittany move?
Log.
Mess up in math.
Yeah, she
Log.
moved after, like, 2
We'll actually get to logarithm
years
next chapter.
with
Log.
Jason.
Oh, not algorithm. Logging.
Logarithm.
Log.
Oh, they said algorithm.
She was like 7
I really
left.
hope
so. We write this
Studio
one,
apartment.
this one, right?
So I have a logarithm.
How they do it.
Log.
That's like that square root.
No, they
Oh,
have
oh.
John Ciara's mattress, they have Cole's blow-up
And
mattress,
we're gonna have X
Jason
on the inside,
Baby's
right?
blow-up mattress, and then I assume Brian just sleeps on the couch.
The hell?
When
They
he
all
stays
are
there.
rugged. They are rugged.
I like these places now, so they have room in the morning.
They do.
That is useless.
Exponent on that X is going to be negative 4.
But there's a lot of people living in
Yeah, I
there.
would
Always
hate to
I
live
see
there
them
just
all
because
on
I'm
Brittany's Snapchat.
Using logarithm.
saying, I couldn't even stand
This one
Brittany
is
by
like
herself.
the opposite. You're going from this back to
The
this.
car, I freaking love it so much. Like, the phone, it's just not
Who cares what other people do?
Alright. Alright, let's go to this one real quick. So we are at
Mamma mia.
Mamma mia.
Alright, so, Devin,
Go.
What?
what is x to the negative 4 over 6 in radical form?
It's the negative. Square root of 6. Or no, 6. 3, 4.
What's this little number in front called?
The index, yeah.
There you go.
That's 6.
Index of 6.
And then you go x to the power of negative 4.
Yep, there you go.
Wow.
Just times it together and you
Just had to phrase it right.
I just
Go.
Alright, Jaden, what is my exponential form of the 5th root of x to the 4th?
What is this? Oh my god. Look.
Yep.
Oh.
X to the 4 over 5.
My life
That's
guy.
it.
Go.
What?
Why can't we learn how to do like interest rate and stuff like that?
We will. Once we get to
Is that
logic.
that fun stuff you're talking about?
Oh yeah. Okay. Good stuff, man. Yeah. But today we get out of here at 2:23. 2 minutes early.
2 whole minutes.
I'm crying right now.
This is how exciting this is.
I'm just like,
Alright.
Everyone just get up and walk out. Let's go.
So let's go ahead and we're gonna do this is our last piece that we're gonna look at.
Liar.
I wanna know what is the 4th root of x to the 3rd over the 8th root of x squared.
No idea.
So we did stuff kinda like this yesterday.
Oh god.
Hey, I need you guys to pay attention to our last slide. James?
No, it's not. We still haven't executed.
his face.
Okay. Last slide, pay attention, we'll be done soon.
Okay.
So, we talked about these yesterday. Are these radicals the same?
No.
Now, my index is different, right? So I can't make one big radical. So what I'm going to have to do is I'm going to convert these into exponential form and see if I can get a little help simplifying. So, the 4th root of x to the 3rd is, hey, shush! Quiet. This is like the hard part of this lesson. Alright, I have x to the 3 over 4 over x to the 2 over 8. These are both exponential form now, right?
Right.
What do we say we do when we have an x over x? What do we do with those exponents? Yeah, or what do we do with the exponents? We could write them out long ways and cross them out.
That's the denominator of denominator.
No.
No. Okay, hang on.
I'm lost.
Alright, on our warm-up. On our warm-up here, what did we do with these
Oh!
exponents? What did we do with
Added them. I mean, subtracted
We
them.
subtracted them, right?
I'm not added them.
So,
Circle of life.
This is not life.
okay. So, what I'm going to do is I am going to go through and subtract these exponents. I'm going to have x to the 3 over 4 minus 2 over 8. Can I subtract these right now, though?
No.
No, what do I need to do?
You need to times the 3 or 4 by 2.
Yep, I need common denominators, right?
Oh,
So I can do that
I
by
forgot about that.
times by
It's
2,
been like 8
times by
years.
2. I have x to the 6 over 8 minus 2 over 8. Now that I've done this, now I can actually
4
simplify.
over 8.
I go
1/2.
6 minus 2 is 4.
X over 1/2.
I have x to the 4 over 8, which is really
You already know
X
the
to
lesson's
1/2.
gonna be like 80 freaking problems.
now. So we can go back and forth between different forms to help us simplify. Alright,
So these are just multiplying.
so let's look at part A down here. So we are multiplying square root of 3 times the 4th root of 3, right?
Yep.
So we can't really do it like this, so let's convert to exponential. That's 3 to the 1/2 times 3 to the 1 over 4, right? Okay? So, because I am multiplying, what am I going to do with these exponents?
You're gonna times them together.
Plus them.
Add them.
Add them together.
Plus them.
Add them together. So I'm going to have 3 to the 1/2 plus 1 over 4. Can I actually add these together right now?
Yeah.
What do I have to do first?
No.
Find the common.
You gotta times the left one by 2.
Yeah, we've got to get common denominators. So if I times these by 2, I get 3 to the 2 over 4 plus 1 over 4, which is going to equal 3 to the 3 over 4. That is my simplified answer.
3
Do I have to use the same number?
times
do the next 2?
2.
I think I want you guys to help me out with part B
Aw.
together, because I'm going to go around and ask some people. Alright,
See ya.
Thomas, What do I have to do to start solving part B right
You
here?
do. And no, it just has to be coming out.
I don't know. I have no idea.
Can we put these in one big radical right now? No, because they have different indexes, right?
Yeah.
So, what did we do on this one first?
Numbers.
Yes.
Oh, you timed it? Maybe. Or you didn't time it. I don't know.
What form is this? Is this in radical form or exponential form?
That's in radical form.
Exponential.
Right here. Exponential, right?
Oh,
Because it's got that big exponent here.
Oh, so you
I was
gotta make
thinking
it.
about
Yep. So, our first step is we're going to make it exponential. So, Kayla,
Yeah.
what is the square root of x to the third in exponential form? X to what power?
3/2.
3 over 2, right? Helena, what is the spotted piece? Cube root of x squared.
3. 2 over 3, sorry.
Yep, x to the 2 over 3, right? Okay, let me just separate this a little bit. Okay, Carissa, what am I going to do with these exponents? Since I have a divide sign, right? Am I going to add these exponents together or subtract them?
Both.
What did we do in our warm-up when I had something over something?
Oh.
We're going to minus them, right? So we're going to have x to the 3 over 2 minus 2 over 3. Mm-hmm. So we are subtracting those two exponents. Alright. Raven, do I have common denominators? No. So I got a 2 and I got a 3. What number should I make both of these be so that they're the same?
Oh. Sorry, man.
What is it, Raven? 6, right? Alright, Ermiah, what do I have to multiply the first one to get by to get 6 on my denominator?
3.
So we're going to times by 3. LMA, what do I have to multiply the second one by to get 6 on my denominator?
Yeah.
Alright, so we are going to get x to the, let's see, 9 over 6 minus 4 over 6. Listen, when I actually go through and subtract those, what do I get? Yeah. X to the 5 over 6. There we go. That's it. Alright. Last in-class problem. I want you to simplify part C. Simplify part C. So on your own, simplify part C, then check with somebody sitting by you.
7.
Bro, she's growing.
I need to change. Now we can do this.
Alright, last in-class problem. Go through, simplify it.
Oh, what did you do? All 4 of them?
I have a question.
Part C.
Well, yeah, I have a question.
I know, I'm trying to figure it out.
What would it be? This is 2, but what? That's a 1. Oh, 2. Times them. How do you tell?
I'm so confused.
When you times, you add the exponent.
Oh, yeah, right.
How would you determine whether you divide? What do you do when you have something outside points? You put this one. Multiply it by multiply, right?
So,
Do we have to split that or something? You do it first.
Okay, I don't know why it's going on, but nice.
What?
I did it much longer.
Austin, what's the answer?
Tuesday.
What one?
You
C.
can multiply it.
Oh, 7, 5, 6.
Ooh.
How are you going to make your exponents?
Maybe number one.
Make your exponents have common denominators.
It's
You have
just,
to multiply them both by
it's
something.
exponent over index. So it's like 3 index is 25.
Thought you could simplify that.
125, you probably can't simplify 125.
That's 5.
How do I know when it's supposed to be minusing or if I'm supposed to be plusing?
Yeah, that's fine.
What is this right here? We're gonna multiply it.
It's just 5.
So when you multiply, add it.
But then that cancels it.
This one had to be divided.
It's just 5.
Alright, another minute or so, then we're going to start going over it.
of his time, and I was just looking at what I was writing in his file.
We're canceling out because it's pretty much 5 square root of 5 times square root of 5.
Remember, when you don't see anything, it's automatically a 2. Square root of 7 and the limit of 2.
This is fine.
That's the multiply, right? And then that's gonna be 7 to the, what's this one?
I really push you, project.
Straight up feel like that was you.
See, I thought it was earlier, so I picked it.
Hey.
Oh, you made that too.
Dumpster.
I'm all, I'll block it.
See what?
What does that mean?
Really?
I didn't even know.
So, now we can pass together. But 7 to the what?
That's not that much. You probably just have
I
to-
just scooped up your arm.
Oh, I can't do that.
All right, let's start going over this one. Let me just get some more space down here. All right, so we have square root of 7, and then the cube root of 7, right? All right, where did I leave off at?
Where am I? You left off on
Austin. Oh yeah, you were the last one to answer, right? All right, Austin. What is square root of 7 in exponential form?
7 over 2.
Yep, 7 to 1/2, right? Jason, what is the cube root of 7 in exponential?
1/3.
Okay. All right, James. Do I have common denominators?
What?
Do I have common denominators over here?
Yeah.
No. No.
I couldn't see it.
Here, let me help you out, man.
Oh, no, too far.
All right, there you go. All right, do I have common denominators? Okay, what denominator should I get?
3.
Can I make that 2 into a 3? No. What should both these numbers change to be? Let him answer.
I see.
Oh.
Like the least common denominator?
Yeah,
6.
6, right? Okay, so I'm gonna have 7 to the Devin. What do I have to multiply to get to 6?
3.
And so I'm gonna get 3 over 6. Jaden, what do I have to multiply over here to get 6 in my denominator? Okay. We're gonna do 7 to the 2 over 6. All right, and Thomas, we add these together. What do we get for our final answer?
5 over 6.
7 divided by 6.
7 to the
All right, nice job.
over 6.
Nice job. That's it.
That's gonna be.
All right, if you haven't yet, start on your exit ticket. I'll turn on Socrative, and then you guys can start on your homework. The first one, stop number 2 you can do in like 5 seconds.
Can I go to the bathroom?
And then just
I didn't know how to do it.